Hey guys, Sarah here. So today we are going to be going over incomplete dominant corn snake genes. And if you have not been watching the other videos in this series, I highly recommend you do that. The first one goes over Punnett squares and how to make them and how to read them. So if any of these things look really confusing to you, definitely go back and watch that first. And I also have one on recessive mutations and dominant mutations. And so if you are not sure about any of the terms on the board or anything like that, definitely go back and watch the other videos. I will link them in a card above so you guys can go check those out if you are not comfortable with anything you see on the board right now. So incomplete dominant mutations, as I mentioned in a previous video, is when two different mutations come together and they form like a combination morph. So what we talked about before was like amyl and ultra, which are sort of like if you have blue water and red water and you mix them together, they make purple water. Well, regular incomplete dominant mutations, as opposed to the recessive incomplete dominant mutations that we talked about before, the regular incomplete dominant mutations have that effect with the normal type, instead of with another gene. So in the last one, there was amyl and ultra. They are two recessive genes on their own, but when combined, they are incomplete dominant with each other, and they make that combined look. Now, regular incomplete dominant mutations that are not recessive to normal, they're incomplete dominant with normal, have that combination look with the gene mutation that we're talking about and the normal type. So the three that are on the board now are palmetto, mask, and cinder. Now you'll notice in all of the different videos when we were talking about like incomplete dominant recessives and regular recessives, stuff like that, I listed on the board each one that those applied to, and the palmetto, mask, and cinder is all that this applies to. The palmetto was actually the first one to really be proven as an incomplete dominant mutation, and then mask sort of came along with it almost. Maybe not with it in the sense that one happened and then the other happened because of the first one, but mask for a long time has been considered to be a dominant mutation, and in some places it still is considered to be dominant. However, through a lot of different breeding trials from myself and other people, we have pretty much determined that it's actually an incomplete dominant gene. With the heterozygous mask, which is what we normally just call mask. The heterozygous mask is being a low expression mask, and then the super mask, which is the homozygous mask, being the higher expression mask. That doesn't change the pattern a whole lot, but essentially the heterozygous mask will change the pattern and color a little bit, where the homozygous mask will change it a little bit more. It's completely different with palmetto, however. The visual palmetto, and for those of you who don't know, palmetto is a completely white snake. It's leucistic, and it has just little speckles of regular color on it, so speckles of red and black, and sometimes yellow. The palmetto was originally thought to be recessive, and so they just came up with the name palmetto, and then later on tacked on the het palmetto to indicate that het palmetto actually was visually different than the normal type. And a het palmetto is actually very hypo looking. If you breed het palmetto in with anery, it kind of looks like a ghost. If you just have a regular het palmetto, it will be a little bit like, it'll look a bit like a hypo type. So the reason that we use super mask for mask and we don't say like super palmetto for palmetto is just the way that it was originally found and the way that it's been produced since then. So the palmetto was originally found and thought to be recessive, and the mask was found and originally thought to be dominant. So we have differentiated the masks between mask and super mask, and we've differentiated the palmetto between het palmetto and palmetto. And cinder is actually very similar to palmetto. Now, cinder is still considered a recessive gene in most places, but anybody who is experienced in breeding the cinder gene will tell you that the possibly het cinder offspring, well, they're always easy to pick out. You can always pick out which ones are cinder because of the way they look. They kind of look like a Miami type with a little bit of like a rough around the edges type of look, which is sort of what cinder does to any gene that it's mixed with, but when it's in the heterozygous form, it just sort of looks like a Miami. So you'll see a lot of like candy canes that are het for cinder, because really high-end looking candy canes will be het for cinder, and that's what gives them the really nice white and clean background color. So Cinder right now is not 100% considered to be an incomplete dominant mutation, but we are, for those of us who have bred it before, pretty sure that it is incomplete dominant. So it's going to be in this part of the list. I went ahead and used mask for all of the different Punnett squares that we have here. I use Q for mask because, well, Q is like the only time you ever see a Q in a base mutation is in mask, so that's just the identifier that I have for it in my collection. And then obviously X means there's no gene there. I'll just quickly go over these. For those who have watched all of these videos in the past, you're going to know what all of this means, but I will help you interpret it since we have not talked about incomplete dominant mutations yet. Remember, you could substitute this Q for a P for palmetto or a C for cinder or whatever you wanted. So here we have a het mask to a normal, and you get half and half. You get half het masks and half normals. Pretty simple. Over here, you have a homozygous mask to a normal, where all of the babies are your heterozygous mask. Now, this is a good way to find out if you have a mask and you're not 100% sure if it's the higher expression or the lower expression. Maybe it's a little bit in between, you can't quite tell. This is a good way to breed it to find out if it's homozygous or heterozygous. You can just breed it to a normal, and if you get half normals, and then like statistically half normals and half masks, then you know that your mask is heterozygous. If you breed it to a normal and all of the babies end up being masks, then you know your mask is homozygous. Like I said, heterozygous mask versus homozygous is not a huge difference. I will go over mask in a future morph deep dive for you guys so that you can get a better idea of what a homozygous and heterozygous mask looks like, but I'm not going to go through that right now. Here I went ahead and did a het mask to a het mask. And as you can see, we have 1/4 normals that are not going to be mask, and we have half that are going to be het mask and half that are homozygous, or 1/4 that are homozygous mask. The homozygous mask, like I said, is going to be higher expression, where the heterozygous masks are going to be lower expression. Now, in the case of like palmetto, if you were doing this in palmetto terms, these would be the visual palmettos. These would be the sort of hypo-looking-ish babies, and then these would be the normal-looking babies. And if you want to go back through here, you know, if you had a regular palmetto and you bred it to a normal, all of those babies are going to look like those hypotypes. And if you had a het palmetto and you bred it to a normal, half of them are going to look like those hypotypes and the other half will look normal. And if we go here I just have a homozygous mask to a heterozygous mask, where you have half homozygous and half heterozygous. Again, if you were going to do these in palmetto terms, you have a visual palmetto to a het palmetto, so half of them will be visuals and half of them will be the hypo-looking types that are just het for palmetto. So I hope that helps. I hope that clears it up for you. Cinder is going to be a lot like palmetto, where you have your sort of Miami-looking babies as opposed to your hypo-looking babies. But this is kind of one of the more basic ones to do, and it's actually probably one of the most straightforward. A lot of people, they're like, oh, if I just breed this to this, then I'll get this. And in this case, yeah, you will get that. This is one of the more simple ones, which I'm really hoping that this video is a bit shorter for you guys. So if there's anything you want me to cover, leave me a comment down below and let me know. Like I said, I will be doing a morph deep dive on mask in the future so that you guys can get a better idea of what mask is and what it does. And I will probably be doing another one of these. We'll see if there's any comments left down below of anything that was a little weird or that you guys didn't quite understand. I will clear that up in a future video. Thank you so much for watching. I'll see you in the next one.